To prepare the calibration standard, prepare your second burette with the working stock solution, filling it to pre-rinsing it several times and filling it to a known starting volume and removing all air bubbles from the burette. Anytime you're doing a spectrophotometric method of analysis, you need to determine by trial and error for the spectrophotometer instrument that you'll be using the wavelength at which absorbances are at its highest. In order to do that, you need a calibration standard containing your analyte, in this case iron. We'll start with like an intermediate concentration. The burette can only deliver a maximum of 50 milliliters, so a middle concentration would be the delivery of 25 milliliters of working stock. So we're going to drain 25 milliliters of working stock into your 100 milliliter volumetric flask. Record the exact volume of working stock used, as this can be used as one of your calibration standards in your Beer's Law plot. And the exact volume needs to be known in order to calculate the exact concentration. Complex the iron to by adding 10 milliliters of the orthophenanthroline and allow the color to develop for 5 minutes. After the 5 minutes, use deionized water to dilute this standard exactly to the mark. You can pour water fairly rapidly until it reaches the neck, and then slow down your delivery so that you don't over dilute the mark. And then after getting the solution meniscus exactly on the mark, cap these solutions tightly and mix 3 to 4 times by inversion. Determining the analytical wavelength also requires the use of a reference or a blank. The blank solution is prepared by delivering 10 milliliters of the orthophenanthroline into a 100 milliliter volumetric flask and diluting to the mark with deionized water. Obviously this solution is clear because there is not any iron, your analyte, in this solution. Okay, and then mix 3 to 4 times by inversion. So at this point you've got a blank and you've got a calibration standard. Prepare 2 cuvettes, one with the blank solution and one with the reference solution, and as you obtain your cuvette, to make sure that it's oriented in the spectrophotometer the same way every time, you want to go ahead and mark one of the faces. I used a marker to put a dot there at one of the top faces, and then that serves as my alignment marker. To properly pre-rinse a cuvette with the solution that you want to get absorbances on, fill it once and discard it, fill it twice, discard it, fill it a third time, and then that's a solution, the cuvette volume that we'll measure absorbance readings from. At that point, you want to make sure that you fill it at least 3/4 of the way full, and go ahead and use a chem wipe to wipe off any extra solution or fingerprints that may be on the outside of the cuvette. Okay, from there on, make sure you handle it from the top. Okay, likewise with your well mixed standard solution, it's a good idea to probably go ahead and mix it again if it's sat for any period of time. Pre-rinse that cuvette with that iron standard, filling it once, filling it twice, discarding each time, and then filling it a third time, at least 3/4 of the way full, using chem wipes to wipe off any extra fingerprints, any air bubbles that you may notice in the cuvette. You can finger flick those out. Okay, anything like fingerprints, extra solution on the outside, and air bubbles, scratches can all interfere with the absorbance reading. To determine the analytical wavelength For this procedure, you're going to start at 490 nanometers. You can change the wavelength using the dial over here. You want to make sure that at that wavelength that you have the appropriate filter selected. In this case, this needs to be filter number 3. There's a wheel behind the sample compartment where you can adjust that. We want to zero it at this wavelength. So placing your blank cuvette inside the spectrophotometer, make sure that you press the cuvette all the way towards flush on the bottom. And then we're going to work in absorbance mode. This is a toggle switch that switches between transmittance mode and absorbance mode. And if you press this button here, it'll set it to read 100% transmittance or 0 absorbance. Once the display says 0 absorbance, you're then going to record the absorbance of the iron standard simply by placing that cuvette that contains that standard mixture and recording the absorbance. Process is repeated by now changing the wavelength to 500 nanometers. At 500 nanometers, we need to re-zero it with the blank. After zeroing it with the blank, record the absorbance of the iron standard at that wavelength. Absorbance of 0.205. Okay, from there, we're going to go up to 510 nanometers, zeroing it. Recording the absorbance. Okay, going up to 520 now. Zeroing it. And recording the absorbance. Do make sure that your spectrophotometer has had at least a 10 to 15 minute warm-up period before you begin taking any absorbance measurements, so that the lamp has a chance to warm up and give you accurate readings. Okay, and then the last increment here is 530 before we're going to make some refinement measurements. Okay, after zeroing it, checking the absorbance of the standard at 530. Okay, so the pattern that you may have noticed is that it kind of reached a peak and started to go back down. Where we're looking for the exact wavelength where we're going to get the peak absorbance. So in those 10 nanometer increments, 510 is where we initially had a peak. So we want to check 5 nanometers above and below that, going every nanometer, every 1 nanometer. So I'm going to start at 505 and work my way up 1 nanometer at a time up to 515. Okay, zeroing it first and then getting the absorbance of the standard. So at 505 we have that recorded. Changing it to 506 now, zeroing. And recording the absorbance. Okay, on to 507. So you would repeat this process through each one of those wavelengths until you found out where you have the highest absorbance. In this particular case, 511 nanometers gave the highest absorbance. So for this particular spectrophotometer, 511 nanometers will be the analytical wavelength to use for this analysis for the rest of the samples, standards and